Within the I/O configuration of the controller organizer, we begin by right-clicking the backplane and selecting New Module. The backplane contains the communications network over which the controller communicates with modules that are local to the controller. Thus, local hardware modules are simply those modules with which the controller communicates over the backplane. In this initial example, we are adding a module to the 1756 backplane of a ControlLogix controller. When the selection window appears, we need to locate and select the desired module. There are several ways to find the desired module. First, we will notice that the list is already constrained to only those modules that may be connected to the particular backplane. For example, we will not find 5069 hardware in the list when we are adding modules to a 1756 backplane. We can use the filters on the left to further narrow down the list by module type, such as communication, controller, or digital. We may also use the filters on the right to narrow down the list by vendor, such as Molex Incorporated, Rockwell Automation, or ProSoft Technology. As an aside, it is important to note the availability of Encompass partner hardware. This is of enormous benefit to customers who, as a result of this integrated architecture, have access to virtually any hardware type that they might require for their application. All of this hardware may be added and configured in a similar fashion, using the same software, minimizing training that might otherwise be required for disparate configuration software packages. Be aware that if we do not see the filters, we simply click the Show Filters drop-down button. We can also find a module by typing a portion of the catalog number or description of the desired hardware in the search box. Once we have located the desired module, we select it from the list. If we want the selection window to close once we've created the module, we check the Close on Create checkbox. Then we may click the Create button. In the New Module window, we begin by entering a name for the module. Then we need to select a slot number for the hardware. In this example, we are adding hardware to a 1756 chassis and, as with the controller, the hardware may be in any slot of the chassis. The slots are numbered from left to right, starting with 0, so we can simply count the slots until we reach the applicable module and configure the slot in the New Module window to match. It is important to note that this is the address to which the controller will go to communicate with the particular module, so the slot number must accurately represent the physical location of the particular module. Optionally, we may enter a description for the module. Next, we click the Change button so that we can configure the module definition. In the Module Definition window, we can select the firmware revision. Be aware that this is simply telling the controller what firmware revision to expect in the module. It will not change the actual firmware installed within the physical module. Directly related to the configured firmware revision, we must now choose the desired electronic keying functionality. Electronic keying can prevent a controller from connecting to the incorrect module. We will choose Exact Match when we only want the controller to communicate with a physical module that matches vendor and catalog numbers chosen in the Logix Designer project, and that has a combined firmware revision installed that exactly matches the combined firmware chosen in the Logix Designer project. Exact Match is typically used in regulated industries that must pass inspection. Thus, if a module is changed out and a different firmware is installed, the Exact Match keying will prevent the system from running until the configuration has been updated and the system has been re-inspected. We will choose Compatible Module when we only want the controller to communicate with a module that matches vendor and catalog numbers chosen in the project, and that has a combined firmware revision that equals or exceeds the combined firmware chosen in the Logix Designer project. For example, if we configure the firmware in the project as 5.1, then the firmware in the physical module must equal or exceed 5.1 for the controller to connect to the module. The third keying option is Disable Keying. This means that the controller will attempt to communicate with the module at this address, regardless of vendor, catalog number, or firmware. We must be extremely cautious when using Disable Keying. If used incorrectly, this option can lead to personal injury or death, property damage, or economic loss. Rockwell Automation strongly recommends that we do not use disable keying, and if we do use disable keying, we take full responsibility for understanding whether the device being used can fulfill the functional requirements of the application. We next need to choose a connection. If we want the controller to own the module, then we choose Data. If we do not want the controller to own the module, then we choose Listen Only. When a controller owns a module, it writes the configuration to that module. The Listen Only option only allows the controller to view the data coming from the module. A module must have a controller owner or it will not communicate at all. Furthermore, depending upon the module, it may only be permitted a single owner. Even for modules that permit multiple owners, the configurations in the multiple projects must match exactly. Depending upon the module, we may need to configure other data options specific to the particular module. If we are not certain about these options, we can refer to the applicable user manual for assistance. Examples might include time-stamped data and scheduled outputs. When we click the OK button, if we've changed anything in the module definition, we will be prompted to click the Yes button to apply the changes. We may also wish to configure the requested packet interval. This is located in the Connection category. The requested packet interval, or RPI, is the period between communications to and from the controller. The lower we set this value, the more frequently the module will communicate with the controller and the greater the demand placed upon the backplane network. We complete the process by clicking the OK button. Looking at the addition of a local hardware module to a 5069 backplane, we see that the process is virtually identical to adding a local module to a 1756 backplane. However, if we are attempting to add point I/O modules to a compact Logix controller and, when we created the project, we configured the expansion modules to 0, we will not be able to add any modules. This can be fixed by accessing the controller properties and changing the number of expansion modules. Then we may add the modules just as we would for any other controller.